Well, lasers have been around a long time, since the 1970s. Lasers are a way forward to reduce environmental costs, reduce energy costs, and better performance in the production of metal products.
One of the things that ALT is doing is laser cladding, which is applying a layer of material to modify the surface properties. You can use a bulk of material at a low-cost material, but the surface properties using very high-quality materials.
Well, the idea is to develop a formation, sol gel, that will harden a component without changing its dimension. The substance we've got changes the hardness from 200 Vickers to 1,000 Vickers, 5 times better performance in hardening. It's a big move forward in hardening components.
Sol gel is going to allow manufacturers to make soft metal components hard up to maybe about 1,000 Vickers without actually changing the dimension. So there will be a reduction in machining effort and therefore machining costs.
We just interact the sol gel with the top surface of the material. We don't want to affect the substrate, just the top surface. I will show you some samples.
One of the projects we've been involved with advanced laser technology is this sol gel project. We've secured Innovate UK funding as part of a highly competitive materials competition. We've discussed with potential industry users also to look at how the sol gel recipes can be enhanced. A key part of our role is on the exploration and dissemination, looking at again, the business model and introducing the research results to end users.
If we look at some of the production-based companies, those people are adopting lasers in quite high numbers, really for profitability. They're in a situation where the laser can bring quite distinct benefits in terms of speed, production output, quality. It's a more profitable process.
There isn't one universal laser that suits all applications. A laser that might be used for processing metal, you wouldn't use for plastics, so we need different laser technologies.
With a laser you can clean certain metals as if you've dipped them in hydrochloric acid. It's very precise, very clean.
We've been working with ALT for about 18 months. We initially sort of engaged with the company to understand out what was their sort of the growth barriers they were facing.
Next 10 years we expect to see lasers much more common in industry. Not just a big company tool, but a frequent tool. That if you're a small firm undertaking precision engineering work, one of the first things you'll be looking at is a catalogue of lasers. We're at the edge of technology looking for new things, and actually very patriotic, and we're making British companies much more competitive.
This is the type of event that we really look forward to. This is really important for us because we're now in a position where we have the opportunity to talk directly to the end users, people that can take laser technology and apply it into industry in the UK. An enormous benefit, I think, to the UK industry in general.
Lasers in the UK are not as well used as in other competitive economies. For example, Germany has 10 times greater laser use. So I almost feel evangelical about promoting the use of lasers among manufacturing technology, and that's what we wanted to do, to show businesses that lasers are applicable for many occasions, many applications, and are actually well within the cost resources of small to medium-sized firms.
Thank you.